All right, good morning. Today, our main topic is about FET amplifiers. So, we've spent an ample amount of time analyzing FET amplifier circuits at that DC point of view. So, today, ito nang i-apply ta na nato nga na-learn towards designing FET amplifiers, analyzing and designing FET amplifiers. So, maybe for me, dali lang nato ni mahuman, no? Si possible nga this meeting mahuman nato ni tanan kung dili ginadla last 2 meetings lang. Okay? Ano man, aside sa nahuman na nato ang pag-analyze og BJT amplifiers, mas dali na nato ma-analyze no ang FET amplifiers kay analogous sa gid kayo sila og process flow, no? Almost the same na gid kaayo. So while in fact ang isa sa akong mga gamiton nga notes karon today is katong notes na atong nagigamit last semester sa BJT. Kanibitaw nga part, I'm not sure if you'd remember itong 2-port system. Last semester pa ni nga notes ako nang keep o kaning cascaded systems, no? So, I hope kadumdum mo ani. So apil na siya, no? Or I mean part na siya sa kuan. And that makes things easier na because naka-undergo naman tayo before. So siguro ang ato na lang kung ano is say mga points of difference between FET amplifiers and BJT amplifiers with regard to mathematical analysis. So this is a summary. This is a summary of the formulas that nga atong pwede magamit sa pag-analyze sa DC, analysis sa Jfets. Okay? So kung di ka gusto mag-derive, convenient naman ang mga formula, no? This is a table of formulas found on page 450 ebook. Then now, even if na mga formula, kinanglan magyapon na to mano-mano og solve ang ID, no, di ba? Gamit Shockley equation. So, at least, di na to i-derive ang VG or VGS, I mean, if exactly kaniyang mga circuits. Now, sa difference sa FET amplifier sa BJT, no? Sa point of view sa math, there's this parameter na itong gamiton called GM, no? This is called the transconductance. If beta ang sa kuan sa BJT, GM sa FETs, transconductance. It's a mathematical equation derived from Shockley equation gihapon. Okay, GM is equal to, so dali na siya ma-memorize, no? Mag sort of atong pangitang first derivative, no? Gipangita nato ang first derivative sa Shockley equation. So GM is equal to 2 times IDSS over absolute value VP, 1 minus VGS over VP. 1 minus VGS over VP. No absolute value. So nawalang squared, no? Kaya mga atong chain rule, no? Squared na to, setting VGS to 0, mabilin ni negative VP, and so ang derivation is nasa text, but pwede na ito na as is, that this is the formula for GM. No? And this part is the GMO, or GM when VGS is equal to 0. This one. Ano siya? GM null or GM0. When VGS is equal to 0, is equal to 2 IDSS over absolute value of VP. Saka lang. So actually, mo naman yung memorize yun daw. Sa taas. Okay? Now, what's the model for a Jfet AC equivalent circuit? Okay? Now, because the Jfet or the FET in general is a voltage control device, okay? Mara siya gingani, oh. This is the drain, this is the source, the terminal, this is the gate, and this is the drain. So muna ang atong kuan kibali, muna atong transistor, field effect transistor, no? Within aning boundary. So this is the internal resistance of our transistor RD, no? RD siguro siya because of the drain, no? Drain resistance, drain to source RD. And voltage lead VGS. And this is the dependent current source. So this is the current from drain to source. If our device is a voltage controlled current source, so dependent ang atong output current VDS, IDS, dependent siya sa input voltage VGS. So output current IDS is equal to VGS times the transconductance, transconductance factor. So GM VGS. And that's it. Muna itong model. So every time na tayo analyze nga circuit, the same process bitaw nga itong gigamit before sa FET, sa BJT, ito lang i-replace o gingani. For example, let's go directly to a self-bias, no? Kaya naman tanan, no? So self-bias na akong kabitong example, but all analysis involving FET amplifiers is the same. So we know nga ang circuit sa self-bias ka transistor looks like this. Naday bypass capacitor here. Okay. Device. So sa itong steps before sa BJT, kung ato nang i-transform sa iyahang AC equivalent circuit, all voltage sources is short, all capacitors is short, and okay. Chapter 5. Diba? Set all DC sources to 0 by replacing them by short. Replace all capacitors by short. Remove all elements bypassed by the short circuited equivalents. And then withdraw. Mga naman to, i-short laman ang mga DC o mga capacitors. Okay? So, i-replace na to ni kaning device na to. Gate, source, drain. I-replace na to kanya itong equivalent such that ma-transform siya to something that looks like this. So again, capacitors, short, short, short ni, batungod ka na i-bypass capacitor dire, mawala na ni si RE. RS. Mawala si RS. Ano naman dito RG dire. RG. Okay, self-bias man dahil eh. Okay. Okay. Si VDD mawala. Okay, ma-short mo na siya. So, marking ani, no? Drain, gate, uning gate, source. Okay. So, meron siya ginani. Okay. VI, VO, input impedance is measured here. Output impedance here. Okay. Supposedly, man si RE. RS. Kani siya, oh. But, na-replace siya og short because na may bypass capacitor here. So, ang current na to dili mo agi. No current will pass through RS. So, nawala siya. Such that, pwede na to ma-simplify pag more ang atong redrawn circuit into naging ani. Mula 30 din. Okay. So malasyag katong gyapong kuan, di ba? Malasyag katong atong self-bias gyapon or emitter bias sa kuan BJT. Input impedance is clearly RG. Okay. So input impedance is clearly RG. Output impedance is RD parallel R, small RD. Okay. So ZI Our input impedance is RG. No? Klaro man siguro. Output impedance is equal to RD parallel RD. Big RD parallel small RD. Voltage gain. Voltage gain is VI over VO. And what is VO? VO is wait. Say voltage drop dire. Negative VG, negative V, say voltage drop here sa VO is ano ang current pa no? So VO is the current. Supposedly VO is measured current man nga flow dire. So negative GMVGS VO is equal to negative GMVGS times RD parallel RD. Okay. Ang expression sa VO. Ang expression sa VI is equal to VGS. No? VI is simply VGS. Therefore, voltage gain is equal to VO over VI, output over input, is equal to, cancel ang VGS, negative GM times RD parallel RD. So, negative GM RD parallel RD. Okay. So, these are our formulas. The same analysis ang gamiton sa pag-obtain sa input impedance, output impedance, and voltage gain of all the other configurations. So, okay. Self-bias, bypass, etc. Input impedance is RG. Output impedance, RD parallel RD. Pwede lang approximately equal to RD if masatisfy na yung condition. Usually, pwede na natin na i-ignore para ma-incorporate yun si small RD. Kanya itong gamitan. Voltage gain is this one. Negative GM, RD parallel RD. Okay? Such as this one. So again, it's not necessary for us to really derive everything else, especially kung kung ano satisfy na nga general configuration. So kung voltage divider nga may bypass capacitor, we'll use these formulas. Okay? Wala lang ang steps, di ba? Atong gi-take as before. Let's solve an example daw. Okay. An N-channel Jfet. Yes, pabay kulang. Device parameters. Okay. Self-bias, no? Self-bias. Okay. So, find chord impedance, output impedance, and voltage gain. Sige. Solve down ninyo. How much is ID? Okay, sabay magamit na to. Need pa ba ang DC nga? Ano? Need pa ba ang mga DC nga? No. Okay. GM is ang need lang is ang VGS. No? Si ID, di na ganyan siya need. I-obtain. Given VGS lang, meaning the expression for VGS. Si ZI is given, si ZO is RD parallel RD. Ano ba yung formula ni small RD? Or given na siya dapat. Ano siya sa specification sheet, si RD. Or bitog katong, kung sa equivalent ganit ni kanio sa katong BJT? Kasi naka-remember? Mag-set na lang tawag RD. RD is usually set at ito na to sa specs. The same siya niya, given ang RD, kaning small RD. The same ano nila. The same niya ang value. 30K. Okay, sige. Set na tanan. No? VGS na lang. Sige daw guys. Would like to solve for VGS. Given ka ni. mag-DC punta, no? Negative IDRS. Amo to ID. So, isolve po sa ID. Okay, so the expression for VGS for a self-biased Jfet is negative IDRS based on lookup table. But VGS is negative IDRS. Okay. $680. Okay. Ay 18.5 o 1.80865. Check akong kung sakto ba ni. -15.6, negative 2.36, and 4 times negative 3. Kung man 18 man 18.5, di pwede because IDSS is 4. Ang isa as 1.80865. Wala tong ID. Therefore, VGS is equal to this one times RS of 680. 1.865 times 168. Negative 1.268. 1.268. Check daw akong math. Okay, mag-lahil answer dili. Ay, okay, okay. Mahirap pala yung given. Tumas yun eh. Mhm. Mhm. Yeah. So, kuha na nato ang GIZO voltage gain. Right. Put impedance is just equal to RG is equal to 3.3 mega ohms. 3.3 mega ohms. ZO RD parallel small RD, big RD is 2.4K parallel 30K. Approximately 2.22K. So, dol-dol na siya sa RD. 2.2. Okay. Voltage gain is GM RD per RD, or negative GM times ZO. So let's solve for GM. GM is 2 IDSS over absolute value of VP 1 minus VGS over VP. Right? 2 times 4 milli times absolute value of 4 is 4. 1 minus VGS is 1.268. Negative 1.268 over VP is negative 4. So, makancel ang negative ni VGS o ni VP. So, muna itong transconductance. GM is equal to how much? Oh, 30K. Diba? So, the ZO is 2.4 parallel 2.4 parallel 30K. Negative? Dili negative. Okay. Sige. Sige, okay ba? Pila man eh. 1 minus 1.268 over 4. Sige. Unit ano yung GM. Per ohms. CGM. Ohms man eh. So, reciprocal sa ohms. No? So GM is 1.366 milli per ohms. So, wala man tayo per ohms. Ang reciprocal sa ohms kay ito, S. Siemens, no? 6 milli Siemens. So, para mo ko ang kuan, voltage gain 1.366 milli times ito kilo ang DO 2.22 kilo voltage gain is 3 more or less. Negative ba ni? Negative. Negative ang formula sa gain. So, negative 3, more or less, no? Okay. Questions? Conform ba siya sa atong guess? So, ang atong self-bias na Jfet is medium range iyahang voltage gain. So, ako na siya na negative 10. So, atong answer is negative 3. Sakto-sakto la. Okay. Questions? Is it clear? The same na ba siya sa BJT? Sige, sige. So, mo yung formula nato for input impedance, output impedance, and voltage gain. No? Ato mo nang i-derive ganina. Kung mo ang atong self-bias na circuit para ma-perform ang AC analysis, ipang short ang mga voltage sources and capacitors. So, redrawing the circuit, manisura. No? And tungod kina-bypass si RS, usan lang ni sa tanan. No? Kanitulo. So, na yung ingani ang atong redrawn circuit. Common lugar kibali si source terminal. No? So, deriving out of this one, si input impedance is just plainly RG. Output impedance is the parallel of circuit resistor RD and internal resistance small rd. No? So, RD parallel RD. And voltage gain is input over output. Input is just clearly VGS. No? Gate man eh. Gate man siya nga terminal. Kanis drain, kanis source. So VI is just voltage drop sa RG, which is VGS. So VI is VGS. VO is using also voltage is IR. Current times resistance. The resistance is the output impedance. The current is the negative GM-VGS. No? Okay. VO is supposed to be the current flowing through VO. But opposite direction man si current GM-VGS. So, VO is equal to negative GM-VGS times resistance RD parallel RD. And if this is VI, this is VO, voltage gain is VO over VI, cancel si VGS. Voltage gain is just negative GM times RD parallel RD. Okay? So, this is just for self-bias. For all the other circuits na dili na nato need, particularly ipang-derive yun tanan, we just refer to our table of formulas. Ako lang ipakita dire kung giun sa pod ni pag-derive ang uban nga expressions, no? Just like for example, voltage divider bias. So mo ni ang mga values for input impedance, output impedance, and apalas lagay is like expression for voltage gain, no? Okay. So if mo ni ang given, ito to. Diba? If mo ni ang given using performing DC analysis, as we've done for the past 3 meetings, we've obtained ID is equal to 1.865 thus VGS is negative 1.268. Okay? So ZI, which is just equal to RG, copy lang. ZI is just equal to 3.3. ZO is RD parallel RD, big RD parallel small RD. Given gyapon ning duha, big RD is 2.4, small RD is 30. Diba? Last but not the least, voltage gain. So si voltage gain, at least a self-bias, no? It's just the product of output impedance and transconductance GM. So GM is equal to this formula, 2 IDSS over VP, 1 minus VGS over VP. Just plug in the values. Patag value nga 1.366 millisiemens. So multiply na to si GM and si output impedance, we get voltage gain 3. Voltage gain is equal to 3. Okay? Okay. Sige. Now, review lang ko gamay ha sa katong kuan cascaded circuits and two-port networks kani, no? So for two-port analysis, we only need those 3 parameters: input impedance, output impedance, and voltage gain. Okay. Now, fortunate for us, the analysis of two-port system, whether BJT or FET, is just the same. So, mo apply gyapon yung mga formulas. Okay? Katong voltage gain nga atong gipang solve yun out from the circuit, and the voltage gain nga naa sa atong mga nasa atong sa table of formulas, kanis lang ang mga voltage gain. These are no load voltage gain or unloaded voltage gain. Okay? So, munin siya, no? So, the voltage gain for a loaded nga circuit with the effect of RL, just like, let's say for example, kanyang atong i-solve ganina, what if nanatay ko andere, nanatay load ng device, no? Or load resistor. Kung gusto nato i-model of resistance. This is the formula, no? I hope this is familiar. AV no load, which is the voltage gain atong i-solve or atong i-look up sa table. AV no load, just multiply it by the voltage divider nga factor sa RL over ZO. So ning ZO, this is the output impedance. RL is the load, no? The load. Okay. Now, if nanatay RS with the effect of RS or source resistance, no? Muna ang formula for voltage gain of with the effect of RS and RL, no? So AVL times ZI input impedance over ZI plus RS. Na siya voltage divider ani nga part dire. Kung atong i-combine using AV no load, no? The voltage gain with effects of RS and RL, no? Is equal to AV no load times voltage divider RL over RL plus ZO times ZI over ZI plus RS. Yan na. Kung cascaded systems, again, this is just a review. The overall voltage gain, no? The overall voltage gain of a cascaded system is just the product, no? The product of the gains of the individual amplifiers. Okay? So comms, unsa inyo na dumduman ba sa cascaded nga system? Unsa ang formula sa voltage gain? Product gyapon or pwede ra. I-upload gyapon ako ni Apil. So sa comms, unsa inyong nadumduman sa cascaded nga system ang mga voltage gain, ipang multiply or ipang add? Multiply gyapon. So the same ani. Okay. Very good. Kung multiply siya, if unitless ratio ang atong given. Pero kung naka-dB ni, di ba, ihata mag-add. Kung naka-dB na nga, kung ato na ipang transform into dB or decibel, instead of multiplying, i-add na siya. No? So gamay lang nga kanang trivia, busa nga dapat ang pinaka first na stage ng amplifier should have the largest input impedance. Ideally dapat ang first stage amplifier, mas better maging amplifier ang BJTs, no? Masyada siyang amplifier ang BJT, especially kung gusto tag high gain amplifiers. But ideally, better nga amplifier ang first stage, better siya nga FET type of amplifier kay dako iyahang input impedance. Nanong important man nga dapat dako ang input impedance? So at least sa first stage, no? Isay although trivia naman no? Maybe na counter nyo ni sa com ang answer ani akong question. Pero wala lang. It's important man for us to know. Why do you think it's important nga dapat ang first stage should have the largest input impedance as possible? Like to guess. Okay, it's called the low noise. I'm on 7 notes. Yes, it's called the low noise amplifier because it should be, no? It should actually be a low noise amplifier. Good, because dili pwede or I mean ang atong noise manggod is lisod na siya lisod na siya itangtang. So ang ato mo amplify mapilog amplify ang atong noise. So if dili pa lang daan nanay noise nga nakasulod, dili lang ang signal ang ma-amplify but apilang noise. So paabot dili ang dili lang katulad dili lang signal ang amplify but pati pa ang noise. So dapat as much as possible sa first stage pa lang daan ma-eliminate na ang noise or at least ma-minimize, no? So yeah, that's correct. It's a low noise nga na amplifier ang first stage. Okay? Balik na dire. If natin mga given nga loaded voltage gain, again loaded voltage gain sila because sa perspective first stage, ang iyang load is the second stage, no? Si last stage na amplifier lang ang iyang load is si actual load. Okay? Especially if 3-stage amplifier siya. Si last stage ng amplifier lang ang iyang load si actual load RL. Si first stage iyang load is si amplifier 2, and so on and so forth. So ang atong ipang multiply nga voltage gains are already loaded voltage gains using this relationship or this formula. Kani. So atong gisolve using DC and AC analysis is this, no? Unloaded voltage gain. So with the effect of RL and ZO, we could obtain these loaded voltage gains. Finding a formula. Okay. Example, si loaded voltage gain amplifier 2 is unloaded voltage gain amplifier 2 times input impedance ni amplifier 3. No? So, sige daw. Balik ka sa itong main example. No? Using this same nakuan circuit, no? Ito na yung connect. Sige daw. Same example. Actually, the same circuit, no? Pareha sila tanan o kuan. O RS, RD, RG. The same gyapon nga IDS as of BP, the same gyapon nga RD. And in parallel siya, capacitor diya, with a load resistance of 1K. Okay? Atong i-solve na karon ang iyahang kuan. Overall resistance. Overall voltage gain. No? But for sure, dili pa siya with the effect of RS kay what may given RS. No? So dili siya 3 times 3. Okay? Because this AV is a unloaded voltage gain or AV no load. Okay? Kaning negative 3. So, pangitaw na to ang nasa man to? Dala, AVL. AVL is AVNL RL over RL plus 0. Okay? AV loaded voltage gain is AVNL RL over RL plus 0. Okay, so pwede man ito mag-draw og kuan. RL. 1 kilo ohm. So because they are both exactly the same, no? Para sila. So atong ZI ug ZO para sad, no? ZI ZO og AB. Ito, 3.3 og 2.2. 3.3 mega, 2.2 kilo, 2.22 kilo. And the AB is 3. No? The same gap on the 3.3 mega, 2.22 kilo, and 3. No? So let's solve for the total loaded voltage gain. The total loaded voltage gain is equal to loaded voltage gain of the first amplifier and multiplied by the loaded voltage gain of the second amplifier. Kung ano yung formula na to? Three. No? 3. Yan eh. Negative 3 na siya. Yeah, sakto. Sakto ma, negative 3 na siya. Thanks. So, negative 3. RL. What is RL sa perspective ni amplifier 1? ZO is yung ZO ha, so 2.22. Okay. 22K. Alright. What is RL sa perspective ni amplifier 1? Ang unsa ni amplifier 2 ang load ni amplifier 1. Yes, si ZI. No? Okay, kung amplifier pa din naka-connect dire, no? Sa dili siya source. Amplifier naka-connect dire. Ang iyahang makita nga load is ang input impedance ni next amplifier. So ZI. ZI ni amplifier 2 which is 3.3. 3.3 mega. Ako ba? So, I think 3 ra gyapon, no? Di mas yung mag-matter ang 2.2 kilo sa 3.3 mega. 2.99. Negative 3 ra gyapon, no? So, si AV, loaded voltage gain of the second amplifier, negative 3 times 1K. Okay. So, lahi na sila. Delay 3 times 3, no? RL niya is 1K man di ay. 1K over 1K plus 2.2. 2.22K. Kaning 2.22 is iyahan niya nga 0. Ilan man eh? 1 over 3. 1. 0.93. Therefore, total loaded voltage gain is the product of the two, -3 times 0.93. Nasa mga -2.8. Is this clear? Any questions? So ako na yung pang-upload tanan nga notes na to today. Namtay tulo ka page plus kani. Yeah. Okay. Kaya ra di ay ang isa ka chapter karon, no? That's already, well, most of it is already chapter, the whole chapter 8 of our book. So yun naman siguro ni kung natay kuan, practice, ba? Yeah, muna ta chapter 8. Next, pwede gid ay nga next meeting. Siguro practice sa siguro ta next meeting. Pwede lagi din nga next week is chapter 9 na ta, frequency response. Normal. Sige daw. Kaya basin ako yung na-overlook, no? Okay, try to check daw. So, itong next topic after ani, after moment sa chapter 8, maybe mga next week na siguro, would be frequency response. Amplifier frequency response. Yeah, positive na din siya. Sorry. Okay. Practice at the next meeting. Sige. I think most of it is pretty clear. Try to review na lang our recording and the notes na akong i-upload.